In this section, we'll be looking at a second way of solving a hypothesis question involving two means. So we're going to be working in this case with a sample data set that you need to open up from your text. So keep in mind when you're opening up your stats crunch from the Blackboard side, instead of going straight to the website, you need to click on the other link which opens up the data sets, and you're going to want to open up data set 5. So go ahead and take a few moments, pause the video here, go through those processes and get your data set 5 open, and then we'll proceed through the steps of solving the hypothesis problem. Okay, now that you've got your data set open, let's go through these steps in solving the hypothesis question. And as you see, these are exactly the same steps we followed for section 8.2, and we're going to continue to use them across the rest of the semester. Regardless of the particular type of task that you're solving for, you're going to follow these same basic steps. So the first thing is checking our requirements. So if we're looking at these particular data set, we have every reason to believe that this is a simple random sample. When we're looking at this, we can see that our n for both groups is not greater than 30. So here we're going to assume that the populations are in fact normally distributed, so we can proceed forward with our analysis in this example. But do keep in mind being careful about that for other problems when they're describing them for you. So we're going to be moving forward with our requirements, and we're going to be identifying our claims. And as I said before, I have to find it easier, in fact, to start with steps 3. So let's skip down to that, where we're seeing we have the claim that the mean IQ score of people with lower levels of lead is higher than the mean IQ score of people with higher levels of lead. So if we're going to set that up, we know we're working with our population parameter of mu, right? So we already have that. Then we need to look at that, and we need to put that in terms of a symbolic formula. So that is going to look like this: mu1, so mu representing mu1, group 1 being the individuals with low levels of lead, and group 2 being the individuals with high levels of lead. So we're assuming they're going to be greater than. And then we're going to set our null to the equals value. And now we're ready to put these in our terms of our hypotheses formula. So we're going to have, again, our null is the equals to formula, and our alternative hypothesis has the greater than. So now that we have that, we have our alpha levels already been given to us as 0.05. And so now we're going to use the stats crunch to determine the p-value. So you want to, when you're opening your stats crunch, like we've already said, select the open data set from the text and open up data set 5. Once you have that, we're going to need to move the data just a little bit to be able to solve for the particular formula that we want to use. So it's set up in a way that's not conducive to doing a t-test. So the first thing we're going to do is we're going to go over and we look in the column labeled lead. You can see that all the groups labeled with 1, that represents the low levels of lead. So this information is included in your text if you're looking at the appendix. So if you're reading that paragraph in the appendix above the data set in your text, it gives you all of this information. So you may want to go take a look at that for a few moments and read through that so you can identify the pieces that we're going to be looking at from this data set. So 1 represents people with low levels of lead, 2 represents people, or 3 represents people with high levels of lead. So that is the problem that we're solving for. But we need to produce these in order to do a t-test. We need to put these as 2 separate columns of data. So we're going to highlight all the values in the IQF column that correspond to value 1 in the lead column. IQF is the full IQ score. We're going to move those over and paste them into an empty column and label at the top low lead. So stop the video here, go through and make sure you get those steps done correctly. And take a little bit of time in highlighting it and moving. You're going to have to use your copy paste options. And make sure you're moving the full data set. So once you've moved all of those variables, go back and check and make sure you didn't leave off a number at the top or the bottom. That's really easy to do if you're trying to move your values too quickly. Now you're going to move all the values in the IQF column correspond to the value 3 in the lead column, and you're going to paste those into another empty column right next to the one you've already done and label it as high lead. And again, be careful with your copy and pasting. Make sure all of your values have moved. And then when you have that, you should have a stats crunch data set that looks like this. Actually, the top value for your high lead is going to be 82. not the 93. Mine cut it off when I moved. I just put the 82 at the bottom. So, which doesn't matter the order here in this particular problem. So you should have a data set that looks like that. And now we're going to go through these stats crunch steps here on the right. So you're going to open stats, tstat, two sample, and data. And you should get a dialog box that looks like this. So we're going to go and select the values for sample 1 is going to be our low lead. So go through and select that column of information. And then go through and select high lead for your sample 2. Now, when we're setting up our hypothesis test, we need to pay attention to what our test and our null hypotheses are. So notice when you're looking here at our null and our alternative hypothesis, we need to set these up so they correspond with the setup on StatsCrunch. So if mu1 equals mu2, which is proposed in the null hypothesis, then mu1 minus mu2 is going to equal 0. Thus, we're going to set that equal to 0. If mu1 is greater than mu2, then we're going to expect to see that mu1 minus mu2 is going to equal a value greater than 0. So that's what we're going to set up for our alternative. All right. So remember, when we're solving the hypothesis test, we're always testing the null. This is what we reject or fail to reject. So that's the hypothesis test that we're solving for is mu1 minus mu2. Okay, and we're setting it up for the null being equal to 0, and here we're setting it as being greater than. Make sure you turn off your pool variance. That will throw off your numbers. It's one of the most common mistakes people make. And then once you have that all set, calculation, and you should get something that looks like this. So your p-value here is going to be 0.0132. And notice it also gives you your t-stat value, your t obtained. So you can use this for solving the critical value approach as well. So now we've got our p-value here of 0.0132, and we need to plug it into our equation for step number 7. So it's going to be, p-value is going to be 0.0132, setting it to be less than or equal to 0.05, and asking ourselves, is this a true statement? Is this a true statement? Is 0.0132 less than or equal to 0.05? Yes, it is. So we reject our null. And this is the image of how happy we are when we do a research project that we've worked on for 6 months and we reject our null because it means we were, in fact, correct with our idea. So we are very happy. Now we have this set. We're going to restate our decision in non-technical terms, addressing the original claim. So here we're going to say there is sufficient evidence to warrant rejection of the claim that the mean IQ score of people with low lead is the same as the mean IQ score for people with high lead. And this supports the alternative hypothesis the mean IQ score of people with low levels of lead is higher than the mean IQ score of people with high lead. And this concludes this video.